Hello and welcome to helpyourmath.com. In this video, we are going to take a look at expected value. Expected value is something where we look at putting money on something and deciding whether we're more likely to come out in the positive or the negative. Let's take a look. The expected value of a discrete random variable is denoted by E, and it represents the mean value of the outcomes. It is obtained by taking the value of that event, of one event, multiplying it by the probability of that event, and adding these products of all possible outcomes, including losing. So we have to keep in mind, usually we only look at but I could win $10,000. That's nice. But, what are you putting into it to be able to even qualify for the $10,000? Is it worth it? So we take each of those, we add them together, and that tells us the expected value. Expected value can be negative, positive, or zero. If it's positive, that's a good thing for you. That means you're going to come out likely. It's more advantageous to take this risk than not. If it's negative, you have to consider your options. And if it's zero, it seems like there's not really a point because you don't really stand to gain anything. You also don't stand to lose anything either. All right, so let's look at a few examples. First up, we have a crazy friend who apparently is really bored because they say, here's a six-sided die. If you roll a 4, I will give you $30. But if you roll any other number, you have to give me $12. Should you take this bet? And for our sake, what's the expected value? We're going to first look at the winning thing, right? Because let's start positively. What's the probability that you actually do win and you roll a 4? We would say the probability of a 4, there's 1 4 on a six-sided die, so the probability is 1 in 6. What is the probability that you roll a number besides 4? So probability of 4 complement, well, that would be every other number. There are 5 other numbers, so we would have a 5 in 6 chance. Now, remember that formula. The formula is taking this and adding up a bunch of these. So the first event is rolling the 4, and if we roll the 4, we get positive $30. Yay. The probability of rolling a 4 is 1 in 6, so the probability times the value is 30 times 1 over 6. That would be positive 5. Okay, the second event is not rolling a 4. So this is a 1, 2, 3, 5, or 6. We have, we're going to lose $12 here, so that's a negative $12 for us. And the probability of this is 5 out of 6. We're going to multiply the value of minus 12 by the probability, 5 over 6, and we're going to come out with minus 10. And if you don't believe me, you can fact check my multiplication with fractions, put 12 over 1, turn it into a fraction. 5 over 6 is already a fraction. I like to simplify before I multiply, and then I get 10 over 1, which is 10. Now, I did not include the sign. A negative times a positive is negative. And finally, the expected value, we're going to add up the values in this final column. That's positive 5 plus negative 10. Oh no. So my expected value is a loss of $5. I'm going to put the negative in front. A loss of $5. What does this mean? This means you probably don't want to play this game with your friend. It was a crazy idea, and you're expected to lose. So if you do play this game, you are expected to lose $5. Find something else to do. Okay, how about this example? You draw one card from a standard deck of playing cards. If you pick a heart, you will win $20. If you pick any other card, you lose $8. Do you want to play this game? Maybe this is your friend's backup plan. Now this friend pulls out a deck of cards and they're like, all right, new game. So the probability you pick a heart, not pick a heart, pick a heart. The probability that you pick a heart. So if you know cards, there are 52 cards. The 52 cards are evenly distributed into 4 suits. And the 4 suits are hearts, clubs, spades, and diamonds, which means there are 13 hearts in a deck. The probability of drawing a heart, then, is 13 out of 52, or we could simplify that just by the suits, 1 in 4, right? Because 1 in 4 cards will be a heart. What is the probability that you don't pick a heart? So probability of heart complement. Well, I'm going to use the 1/4 because it's the complement of that, so it's the rest of the 4. I already have 1 accounted for with the heart. There are 3 others, 3 out of 4, that we're not going to select a heart. I like my table. Let's fill in my table. Probability of the event is drawing a heart. The value of a heart is a positive $20. The probability of selecting a heart is 1 over 4. The value of $20 by the probability, 1/4. We get a positive $5 here. How about not a heart? So heart, not. The value of that is minus $8. The probability that we don't select a heart is 3 out of 4. Then we would do minus 8 times 3 over 4. In case you need to see the work, I would put 8 over 1, because if we're multiplying and one of the things we're multiplying is a fraction, I want everything to be a fraction. I'm going to simplify before I multiply. 4 goes into itself once. It goes into 8 twice. I end up with 6 over 1, which is 6. But that was a negative 8. A negative times a positive is negative. Then finally, the expected value, we're going to add that final column. I'm going to do that positive 5 plus that negative 6. And it looks like we are expected to lose $1 on this, which isn't as bad, right? This is a better game. We're getting better. Still, it's not to our advantage to play this game. In the long run, we are going to lose money. Okay, now our crazy friend has gotten even crazier and they've become generous. So now you don't even get to lose any money. Your generous friend offers you $4 if you flip heads on a fair coin and $10 if you flip tails. You can't lose. You're going to get money either way. What is the expected value for a single coin flip? All right, probability of the coin landing on heads. Well, that's 1 out of 2. And the probability of not heads or tails is also 1 out of 2. Let's figure this out. So the event here is flipping a heads, and the value is $4 for heads. The probability is 1/2. The value times the probability, that would be 4 times 1/2, or half of 4 is 2. All right, that brings us to tails. Tails is worth, $10, right? And both of these are positive. I didn't put the plus signs, but they're both positive. The probability of tails is 1/2. So we would say 10 times 1/2, and half of 10 is 5. Then we're going to add these, and when we add these, we get 2 plus 5. The expected value of a single flip, is $7. Positive $7. So yay! That's pretty exciting. And this example is really nice because the probability for each was half. So we see that 7 is halfway between 4 and 10. So it makes sense that that would be the expected value, because it's just taking the average of the events times their values. That makes sense since the two events have the same probability. Let's take this up a notch. So now you have to put money into it to get something out of it. And the New York State Pick 4, you can win $5,000 on a $1 bet for correctly predicting the sequence of 4 digits in the correct order. What's the expected value for winning the Pick 4? And there are other ways to win this. I just want to make that clear. I'm just considering this is, I think it's called like the straight win or something. I'm only looking at the straight win and nothing else, because these can get really complicated. And I'm just trying to show some examples that hopefully make sense that aren't overly complicated. Okay. So let's start with just figuring out what the probability is. What's the probability you get the correct sequence? This is a Pick 4. I believe that it's the 10 digits. So it could be any digit 0 through 9 for each of these 4, right? Because digit is 0 through 9. So the first number, second number, third number, fourth number, this could be 0 through 9. This could be 0 through 9. This could be 0 through 9. And this could be 0 through 9. Each number, there are 10 possibilities. So 10 times 10, and then we multiply each of the 10 possibilities to the second 10 possibilities, which gets multiplied to the third 10 possibilities, etc. So that's 4 tens, or 10 to the fourth. 10 to the fourth is 10,000. So that's the number of possible sequences. You buy one ticket, there's a 1 in 10,000 chance you're going to predict the correct sequence. What is the probability that you don't get the correct sequence? Well, there's one way to get the correct sequence out of 10,000, which means there's 10,000 minus 1 ways to get the wrong sequence, which would be 9,999. The probability we don't get that correct sequence, 9,999 over 10,000. Ouch. What is your expected value? All right, so we have 2 events, right? In this example, don't say that there's other, I know there are other ways to win money, but this is the way you win the $5,000. Okay, so we're going to be really careful when we set up this table because you had to buy into this. You don't just get $5,000. I mean, you do get $5,000 minus the tax. We're not going to worry about minus the tax, but we want to look at the value to you. So the event here is getting the $5,000. I'm going to say winning $5,000. However, the value of this is not $5,000. It's $5,000 minus however many tickets you bought. We're assuming one ticket in this case. So the value is only $4,999. I mean, I say only, but that's still pretty, I would take it. I'm not going to say no minus that $1. The probability of gaining $4,999 is 1 in 10,000. And the value times the probability, that would be 4,999 times 1 over 10,000. And then if I convert this to a decimal rather than trying to simplify, this is nice because this is just 0.49999. Nice. Okay. The second event is not winning. And the probability, the value of not winning, I lose $1. The probability of me not winning is 9,999 divided by 10,000. The value times the probability, that minus $1 I'm going to lose, times 9,999 over 10,000. Well, this would be negative 9,999 over 10,000, which would be negative 0.9999. And then if we add those two probabilities together, luckily these turn out pretty nice. We get 0.4123 plus negative 0.9999. And it looks like we are expected to lose 50 cents. You put in $1, we're not making it back. We are expected to lose 50 cents. Is it worth it? No. Is it the thrill of the ride worth it? I can't tell you how to live your life. It's up to you. Okay, last example. At a raffle, 2,000 tickets are sold at $5 each for two prizes, one of $4,000 and one of $1,000. You buy one ticket. What is your expected value? We're going to just go right to the table this time. I'm cutting all ties with hand holding in this one. Also, I encourage you, as always, pause the video and see if you can get it. Okay. So the first event, this is the winning $4,000. So I'm just going to say $4,000. But the value of this, you paid $5. So if you're handed $4,000, your net profit is $3,995. So this is a value of $3,995. The probability of winning the $4,000, there's one prize of 4,000 out of 2,000 tickets. So that would be 1 over 2,000. Then the value times the probability, we would have 3,995 times 1 over 2,000. Might be helpful to have a calculator here. And I get for this one, 1.9975. Okay, next event, you win $1,000. Still pretty good. But if you win $1,000, how much are you really winning? You're really winning $995. The probability of winning $995 is still 1 out of 2,000, right? Because there's 2,000 tickets total. One of them is going to be selected for the 1,000. Then the value times the probability, we have 995 times 1 over 2,000. And that would give us, and we get 0.4975. Okay, but now we have to consider the other event. The more likely event, the most likely event, you don't win either prize. This would be a loss of $5. So the event is losing $5. The value is minus $5. And the probability, well, there's 2 winning tickets out of 2,000, which means there's 2,000 minus 2, or 1,998 out of 2,000 chance, a probability of not going home with anything. Just sadness all around. I'm just kidding. Okay. So then we would multiply. We get negative 5 times 1,998 over 2,000. We could simplify, but because I'm using the calculator anyway, I would just plug this straight into the calculator. And we get, minus 4.995. So now we take those three values in the right column and we add them all together. It looks like my expected value is negative $2.50. So, I mean, it's a raffle. It's probably for a good cause. You can donate $5 to whatever, but your expected value at the end of the day, at the end of the raffle, is minus $2.50. These have been examples of expected value. Thank you for stopping by.